Have you ever felt like the days are zipping by? It turns out there's a bit of science behind that feeling. Earth is actually spinning a tiny bit faster lately. Scientists are tracking this real phenomenon with incredible precision, and even though the change is measured in milliseconds, it matters a lot in our high-tech world. For decades, Earth was slowing down, but now it's speeding up, raising new questions for the people who keep our clocks in sync. This isn't just trivia, it's a real-world puzzle involving physicists, astronomers, and engineers. Even a tiny shift in Earth's rotation can impact everything from satellites to the way we measure time. We're about to explore how much faster Earth is spinning, why it's happening, and what it means for our technology. From the planet's core to the satellites above, this story shows how everything is connected. Let's dive into the science behind our planet's changing pace. Get ready to discover how these invisible changes can have a big impact on our lives. Let's go. Around 2020, scientists noticed something surprising: Earth's rotation, which had been slowing for ages, started speeding up. Days began to shorten by fractions of a millisecond, a subtle but significant shift. On July 5, 2024, Earth set a new record for the shortest day ever measured, spinning 1.66 milliseconds faster than usual. This wasn't a fluke. It was the peak of a trend, and more record-short days are expected in 2025. Scientists are fascinated, marking their calendars for more possible milestones. The forces behind this speed-up are still at play, and we're all along for the ride. Why now? What's happening inside our planet or in our oceans to cause this? By studying these tiny changes, we learn more about the complex systems that make Earth tick. It's a planetary mystery, and every millisecond is a clue. The race to understand our planet's new rhythm is on. How do we know a day was 1.66 milliseconds shorter? The answer: atomic clocks. For centuries we used the sun and stars to tell time, but Earth's spin isn't perfectly steady. In the 1950s, scientists built atomic clocks, so precise they'd only lose a second in millions of years. These clocks use the vibrations of atoms like cesium as nature's perfect pendulum. Atomic clocks define the second and form the basis of Coordinated Universal Time, or UTC, the world's official time. Your phone, GPS, and even banking systems all sync to UTC, but here's the catch: UTC is based on atomic time, while Earth's spin, UT1, is a bit wobbly. Timekeepers must keep these two systems in sync, so our clocks match the actual sunrise and sunset. With Earth now speeding up, we face a new kind of timekeeping challenge. It's a global balancing act, powered by the precision of atomic clocks. To keep atomic time, UTC, and Earth time, UT1, aligned, scientists invented the leap second. Since 1972, we've added 27 leap seconds to let Earth catch up when it was spinning slower. But now, with Earth spinning faster, atomic clocks are falling behind. The solution? A negative leap second. Skipping a second entirely, something never done before. That means 1 minute would have only 59 seconds, jumping straight from 58 to 00. Our systems are built to add seconds, not remove them, so this is a huge challenge. If Earth keeps this pace, we might need a negative leap second as soon as 2029. The idea of a second vanishing is a scenario most computer systems aren't ready for. It's a practical problem with real-world consequences for the internet, finance, and navigation. Timekeepers and tech experts are racing to prepare for this unprecedented moment. Why is skipping a second such a big deal? Computers rely on continuous, unbroken time for everything: logging events, securing transactions, and organizing data. A missing second could confuse systems, causing errors or even crashes. When a positive leap second was added in 2012, major websites and airlines experienced glitches. Now, imagine the chaos if we take a second away instead. GPS satellites, which need nanosecond accuracy, could give wrong positions, affecting planes, ships, and cars. Scientific experiments that depend on perfect timestamps could be disrupted. Because of these risks, there's a debate: should we get rid of leap seconds altogether, or do we need a new, safer way to adjust time? The negative leap second is forcing us to rethink how we manage time globally. Even in our digital world, we're still tied to the spinning Earth. What's making Earth spin faster? It's a mix of powerful forces. The molten core deep inside Earth can change the planet's rotation, like a skater pulling in their arms. The moon's gravity usually slows us down, but its braking effect isn't constant. Sometimes it weakens, letting Earth speed up. Climate change also plays a role. Melting ice shifts mass toward the equator, which should slow Earth, but right now other forces are winning out. Seasonal trends matter too. Earth tends to spin fastest in July and August. Ocean currents and atmospheric patterns add to the complexity. Experts think this acceleration is temporary. The moon's long-term braking will likely slow us down again. Still, it's a beautiful, complicated system with many moving parts. Every shift tells us more about our planet's inner workings. The story of Earth's spin is far from over. What does all this mean for us? It's a reminder that Earth is a dynamic, ever-changing world. Its spin can speed up or slow down, and science helps us understand why. The challenge of a negative leap second shows how clever we must be to keep our world running smoothly. Science brings people together to solve these puzzles and keep our clocks in sync. You can follow the latest discoveries on sites like timeanddate.com or NASA's website. Next time a day feels short, remember, it might actually be. Share this story with friends and family, and talk about the atomic clocks and the molten core. Understanding our planet is one of the greatest adventures. Our world will keep changing, but curiosity and science will help us keep up. We're all part of this journey, 1 millisecond at a time.